In Module 3, Lesson 2, we're going to use a really cool strategy to learn some of our six facts. And that strategy basically is to use our fives facts to help us out, since those are something that are easy, either we know already or are really easy to solve, and use those to help us. And let me show you what I mean by that. So technically, we're going to be using like the distributive property here, and a bit of the commutative property as well. Um, and that's all well and good, but really, I just want you to understand how to use the strategy. It's more important that you can use it than you can name it. So uh, here's basically what we're doing. Um, I'm going to take the fact 6 times 4 equals. That also could be written, and you'll see this in unit form. Let's get this right out of the way because a lot of kids are going to ask. Unit form equals 6 fours or 6 fours. So let's put that off to the side. You're going to see it in the problem set in the homework. That's what that means. 6 times 4 or 4 times 6, those are the facts. Well, all right, you might say, Mr. Brunel, I don't know. Well, we can figure it out. Let's do it. So we can say that 6 times 4 is the same as 5 times 4 plus 1 times 4, because our 5s are easier to solve. And that equals 5 times 4 is 20. 1 times anything is itself, so that's 20 plus 4 equals 24. So 6 times 4 is 24, and 4 times 6 is 24. Let me show you another example, and I'll do a drawing with this one. You know how I love to draw. So let's do 6 times 7 equals, we don't know yet. 7 times 6 is the other, is the commute, using a commutative property, the turnaround back there. The unit form is 6 sevens, or you could write it 6 sevens, it doesn't matter. Let's put that in a box and put it away over there. And let me draw you a picture of how I'd like you to think of this. So we have one, we're going to make 6 units and they're each going to be worth 7. So I'll put a 7 inside them. 3, 4, we have 6. Now you notice some of them I did in black. And then this last one I'm going to do in a different color, orange. All right, so I have, this is showing me, I should do that in black still, sorry. Right here, that's showing me 5 groups of 7. And then this top one is showing me 1 group of 7. So this is where we get our whole problem. 6 times 7, 6, because I have 6 groups altogether, but I'm separating them to 5 groups and 1 group. That equals 5 groups of 7 plus, because I'm adding it to my 1 group of 7. And then I end up doing this. 6 groups of 7 equals, 5 times 7 is 35. Either I know that right off the top of my head, or I can say 5, 10, 15, 20, 25, 30, 35, because we can always count by 5s to solve those. And then I know 1 times anything is itself, so 1 times 7 is 7. So 6 times 7 is 42, because 35 plus 7 is 42. And if I know 6 times 7, I can know 7 times 6. So I've learned something in the 6th family and something in the 7th family uh, using this strategy. And we're going to get a lot of practice with this today. I'll give you another example here. But this is the process we're going to go through for each problem today. Is we're going to take, whenever you have 6 times something, eventually I want to get to the point where you just know those facts. But until we get there, when you see 6 times something, if you don't immediately know it, you can break it into 5 times that thing plus 1 times that thing. So let's do 6 times 8, or 8 times 6. don't know either right now. Unit form. I really only showing you the unit form because I know that it's something that you're going to see on the homework and the problem set and say, what is this? So let's keep repeating it. It's 6/8. And then I will break this into, I'll say 6 times 8 is the same thing as 5 times 8, or 5 groups of 8, plus 1 times 8. Okay. I can show you a picture of that. Okay. So each of these things is worth 8. I drew them too small, sorry. 2, 3, 4, 5, 6. Whoops, I drew too many. Sorry about that. Let's try that again. I only need to draw 6. If I had listened to myself when I did that last problem, I would have known that. Each of these 6 things is worth 8. Almost every lesson I make a mistake, and that's okay. It's all right to mess up sometimes. As long as you know why, you can go back and try to work to correct it. So I have 5 groups of 8 right there. And I have 1 group of 8 right there. So I've showed in my equation here, I've showed where they come from, like where those things come from. 5 times 8 is 40. 1 times 8 is itself, it's 8. So I have 40 plus 8 equals 48. So the answer to 6 times 8 is 48, and 8 times 6 is also 48. I was planning on that being my last example, but since I messed the drawing up, I'll give you one more. All right. We will do 6 times 9, and 9 times 6. Unit form, just because we've done it in every other one, is 6 nines. All right. Again, I'm going to show you the drawing. Some problems will ask for it, some won't. And again, we're going to make 6 groups of 9. 4, 5, and 6. Okay, so 6 times 9. I can break that into 5 groups of 9 plus 1 group of 9. I guess I should switch color here eventually. 1 times 9. And that 1 times 9, we'll call that the bottom one over here. That's 1 times 9. And our 5 times 9 is all the rest of this stuff. We have 5 packages of 9 here. And we can solve this by saying 5 times 9 is 45. Again, either you know that, or you can say, count 9 times 5. 5, 10, 15, 20, 25, 30, 35, 40, 45. And again, we're adding that to 1 times 9, which is 9. 45 plus 9 is 54. So 6 times 9 is 54. And 9 times 6 is 54. So again, this connects. This is a cool strategy in itself. It's really going to help you in itself, but it also connects back to the work we did in lesson 1, where now that you've learned 6 times 9, you've also filled in part of that multiplication array in terms of, in your head, like your knowledge that you have, you've also figured out 9 times 6 as well. So you haven't just filled in one box on that chart, you've actually filled in 2 because of the commutative property. So using this strategy to learn 1 fact actually teaches you 2 facts. Any questions, please ask. I hope this strategy really helps you. We've done something similar. We've done similar stuff to this before in module 1, but not necessarily with using a 5. But I think using 10. So this should be familiar to you. And we're just applying this same sort of strategy to a new set of numbers. All right, guys, keep up the good work. You're doing great. And I'm really proud of you, all the work you're doing.